All right. Yep. When you guys look at the stuff that we cover, you're like, are you serious? That's where you got to, that's where that trust factor comes in. You guys trust me, right? We're going to be able to do this, okay? We can do this, okay? All right, so we start here, okay? Let's look at a second type of problem with a precise definition limit. We're going to look at 3 sine of 2x. Always, when you begin these type of problems, always start by writing down what we are trying to work with and what we're trying to show. I'm going to write a limit statement. The limit as pi over 8 of 3 sine of 2x. How do I figure out what the limit is? Plug it in. What's pi over 8 times 2? Pi over 4. Pi over 4 is the same as how many degrees? 45. What's the sine of 45? Root of 2 over 2. So we got 3 times the root of 2 over 2. Now, for those of you who didn't remember your trig, we're going to review that. But I'm so proud that you guys remember that because I've worked so hard at that over the years. Trust me, there's been years where I've taught calculus where I've asked people that, and nobody was able to give the answer. And I would say 50% of you knew exactly what you're doing. So way to go. What does that graph look like? Okay, amplitude of 3. Okay, so I'm going to go all the way up to 3. What's the period? Two pi over 2, which is pi. Okay. Okay, what's the value I'm approaching? Over 8. And I've got 3 roots of 2 over 2, which if we convert that to a decimal, we're going to go 2.12. Awesome. So it says find an interval for x values such that the y values will always be within 0.1, which basically means we have an epsilon, we want to find a delta. What's the epsilon? Yeah. I took 3 roots of 2 and divided by 2. What's that? If I take 3 roots of 2 and divide it by 2, I get 2.12. When I plug pi over 8 in, you get 2 times pi over 8 is pi over 4. The sine of pi over 4 is the root of 2 over 2 times 3 is 3 roots of 2 over 2. So that's my limit. But my epsilon value is 0.1. So therefore, what's the top part? 2.22, and the bottom part 2.02. So we know that the kind of the pictures and the graphs get a little bit messy, but we're looking for a general idea of what we should be seeing. So do you want to deal with the 2.22 first, or do you want to deal with 2.02? Okay, so what do I do then? I don't plug in 2.02. What do I do? Nope. Yeah, 3 sine of 2x is equal to 2.02. Now we go. Divide by 3. So I'm going to do 2.02 divided by 3. Go get some brain food. Come back. Smarter. Awesome. You too. All right, here we go. Let's get back to your equation. Sine of 2x equal to 0.673 repeating. What do I do to get rid of the sine? Sine inverse of that answer. I get 0.7387. So 2x is equal to 0.7387. Divide by 2. And you can see I'm carrying these decimals out a fair ways because, sometimes these small values really creep up on us. So I got x is 0.3694. So 0.3694. Then I do the next one. 3 sine of 2x is equal to 2.22. Inverse sine, divide by 2. X is 0.4165. So how is it again that I find the delta value? Subtract pi over 8. 0.0238. Or I take pi over 8 and I subtract 0.3694. 0.0233. So that's why I express the decimals, you know, kind of a long way out. That way I could see for sure which one was smaller. So what should my epsilon value or delta value be then? So correct me if I'm wrong, but I believe that you guys now understand how to write the limit. You understand how to make the lines, and you understand how to find the delta values, right? And you understand that idea if for every epsilon, you can find a delta. Agreed? All right, so what we're going to do now is we're going to teach you that last part. We're going to teach you through a proof. And really, the proof is a nice layout. I know that sometimes your experiences with proofs haven't been your favorite, but trust me, this is going to go well, all right? And we start with writing, there's 2 parts of this proof. And we first write number 1, and we say, find an appropriate delta. And yeah, when you do this problem on a test or an assignment, this is what you need to write. Everything I write is important for the problem. Nothing should really be left out. And so what I do is I want to find an appropriate delta. Notice after delta greater than 0, it says that satisfies. Okay? So I want to find a delta that satisfies that thing. So I'm going to write it down. I got to satisfy this. The absolute value of f of x minus L is less than epsilon when x minus a is less than delta. Okay? Now, we're going to teach you this piece. You really don't understand what that absolute value piece means yet. I'm going to share with you that on Monday, and I'll hopefully be the last where you can finally say, okay, now I get everything. But here's what we're going to do now. We're going to take and plug the stuff in here that we need. What's f of x? Minus, what's L is 13. Very good, Carter. Is less than epsilon. Okay? When x minus a, what's a? Is less than delta. There's going to be a cool moment here for you. Okay, it's going to happen pretty soon. What is 3x plus 7 minus 13? Jeez, people. Okay. Do you see it? Your goal is to make the left side look like the right side. Absolute value of x minus 2 is less than epsilon divided by 3, which is really fun to write. It's really cool. So look here. It says x minus 2 will be less than epsilon over 3. So anybody know what we should choose then for delta? Remember, it's a game. You give me an epsilon, I give you a delta. Okay? So for example, if I chose epsilon to be 6, do you know what you would choose delta to be? 2. If I chose epsilon to be 21, you would choose delta to be 7. You know right away. We don't even have to go through the math. You just know I'm going to choose 1/3 of your epsilon, and it's going to work out every time. So, because of this, we make 2 statements. It said find an appropriate delta. We're going to choose delta equal to epsilon over 3. That's our delta value. It's going to work out every time. Then we're going to make a second statement. And you're not going to entirely understand why we make the statement until we write out the end of the proof. But I'm going to do something. I'm going to take this piece here. X minus 2 is less than delta. Can you multiply both sides of an inequality by something? Is that legal? What if it's negative? Then you have to flip the sign. But as long as it's positive, I'm okay, right? Right? For example, okay? All right. So here's what we have. Choose delta is equal to epsilon over 3. I'm going to multiply that through and get 3 times x minus 2 is less than 3 delta. Now, I know you're going to wonder why we have that piece there, but we're going to make good use of it. So we now have the second part of our proof. And the second part of our proof is to show that last statement. Show that the absolute value of f of x minus L is less than epsilon when the absolute value of x minus a is less than delta. We're going to show that that's true. We just got one line and we'll be done. But this is where all the logic happens. I need to make this statement. There are 3 parts to the statement. There's an absolute value expression, there's an inequality, and there's an epsilon. I will start with the absolute value expression, and I will do so in green. The absolute value of, what's the function? 3x plus 7 minus 13. I can't say that's less than something yet. If you look up here, it just doesn't really fit. Okay? That is equal to what? 3x minus 6. That is equal to what? Three times the absolute value of x minus 2. Is everybody okay with what I've written so far? Now, I've only written stuff in the green so far, right? I need to write an inequality sign. Do we have this attached to an inequality sign somewhere? Right here. So now we can write less than. And as you said, Jake, it's less than 3 delta. Because of what we wrote right here. Okay? I need to get an epsilon. What do we choose for our epsilon? What do we choose delta? I'm sorry. What do we choose for our delta? What do we choose delta to be? Epsilon over 3. We end our proof with the square. Whoop. I should have that written in black so that you can see. Okay, all right. So notice what it says. It says absolute value f of x minus L is less than epsilon whenever x minus a is less than delta. So we've got x minus a is less than delta, right? Now, Maddie, I multiply both sides of this inequality by 3. And I get 3 times x minus 2 is less than 3 delta. See that? So when I had this absolute value of 3x minus 2, I was able to say, oh, that's less than 3 delta. So I've got the less than sign, I've got this, and I came up with the epsilon. So I actually have all the components. This is less than this. And so I've shown it. Question. Okay. Be easier the second time you see it through. We end with one last example. Flip it over. What's the first step? Choose an appropriate so we're wondering what should delta be? Should be epsilon over 5? Should be 2 epsilon? Should be 20 epsilon? Should be epsilon over pi? What should it be? We'll figure that out. Well, we use our definition. The absolute value of, which is 3 minus 2x, minus, which will be plus 5, because of the negative. Very good. Less than epsilon when x minus 4 is less than delta. Okay? So it works out really nice in these linear situations that the left will come out to be like the right. I'm not going to give you something that's nonlinear. Those are significantly more challenging. Okay? So let's go through the work. This becomes negative 2x plus 8 less than epsilon. If I want it to look like x minus 4, I should factor out a, and when you factor a negative out of an absolute value, it becomes a positive. Yep, so I got 2 times the absolute value of x minus 4 is going to be less than epsilon. So x minus 4 absolute value is less than epsilon divided by 2. So I'm going to make 2 important statements that I will use in the proof. I will choose delta equal to what? Epsilon over 2. Second of all, I'm going to make a statement. What should I multiply both sides by? 2. I'll get 2 times the absolute value of x minus 4 is then less than 2 delta. So if x minus 4 is less than delta, then 2 times that is less than 2 delta. Just making that statement. When you factor a negative out of an absolute value, it becomes a positive. Okay, question? We all good there? Okay. All right. So then we go to our second part. We've chosen delta. What's our second part? Show absolute value of f of x minus L is less than epsilon whenever x minus a is less than delta. So again, the definition says the limit exists if for every epsilon there's a delta. Well, we found the right delta. We just have to show that it satisfies this. So let's show that it satisfies this. Absolute value of 3 minus 2x plus 5 equals 2x plus 8 equals I'm going to pause there because all I've said so far is this portion, absolute value f of x minus L. I eventually need to include an inequality sign. Can I now say less than? And why can I say that? Because this guy right here is less than 2 delta. So I've got my inequality sign. 2 delta. Oh, I need an epsilon. So what can I insert for delta? I'm sorry. It's less than. I just put the. I just kind of underlined it so people could see it was there. So where'd you get the epsilon over 2, Carter? Yeah, we chose it. That's what we chose delta to be. What's 2 times epsilon over 2? Epsilon. So the box says I'm done with the proof. QED, box, however you want to do it, okay? So there it is. There's this part in red, there's that part in green, and then here's this part in blue. We've made the statement. Here's your assignment, which we will pick up on Monday. If you'd like to get started on it, go ahead. But I know that there's going to be some questions. Some of the questions in the book are very, very simple. You just may not understand what they're asking, and we might have to talk through it. For those of you who truly love algebra, okay, the algebra of calculus is coming up. Trust me. You get plenty of opportunities to work with x's and square roots and fractions and all that stuff that you love and factor and do all that stuff. It's going to happen. It's going to happen. Right now, we're very conceptual.